Let's start. Hi. Hope you all enjoyed the lunch and ready for the next session. We've got a very exciting session over the next hour. So without further ado, let's start. I'll be hosting the session today and I'll introduce the teams shortly. But my name is Nazar Sufi. I'm Head of Sustainability at Edison's. I have worked at Leeds Council over the past 3 years before joining Edison's this year. I led the PSDS program where we won £50 million of PSDS funding and we decarbonised 80 sites. So that's enough about me though, but let's talk about the presentations today. We've got two really exciting presentations today, both of them on the theme of sustainability and net zero. But the one thing that they have that really comes out from these two is how a strong client desire to deliver sustainability has been taken all the way through to fruition, and also a good partnership with consultants, contractors, to get that vision into reality. So, without further ado, let's start with the first team from ISG and from the Cambridge Institute of Sustainability Leadership. I want to welcome Nitch-Smith and Nick Forrest. And they will tell you a little bit more about their project, Entopia. Thanks.
Good afternoon, everybody. It's nice to see you all here.
It's working 10 minutes.
It was, I know. Am I doing the wrong one?
That way. As in the button that side. And right.
Technical glitch.
Oh, there we go. There we go. It's just a bit slow to respond. I know the feeling. Right. So, welcome to the Entopia presentation. Thanks for that intro. I'm Anna Nitch-Smith. I'm the Chief Operating Officer at CISL. So I'm going to give a brief intro to the project, to the building, and some scene setting in terms of the issues that we've just started to talk about in terms of the collaborative nature of the project. And then I'm going to hand over to Nick from ISG, who was our contractor on the project. Some of you may notice that Nick is not Peter Kelly, who is in the programme. Peter sends his regards and his apologies, but Nick is absolutely as equal in her knowledge and capability on the Entopia building. So just a little bit of scene setting. The Cambridge Institute for Sustainability Leadership is part of the University of Cambridge. We are a mission-led, impact-driven organisation looking at, effectively in layman's terms, raising the bar around leadership and ambition on global sustainability issues. So, in 2015-2016, when we got to the stage where we were outgrowing our existing buildings, it comes as no surprise that we felt the need to do a deep green retrofit of one of the university's existing building assets. I'll not bore you with the statistics that you obviously already know, coming from the built environment sector around the global contribution of carbon dioxide from the built environment, and obviously the amount of building stock that is here already that will be in 2050. So those are the things that led us to a position effectively where we had to put our money where our mouth is. We fundamentally believe that many of the solutions to the global crises that we face right now are here, but that it needs strong leadership, strong ambition, and some pretty awkward and uncomfortable conversations to get that. So, just a bit of a plug for our project partners. There were many of them. There are more than these here, but these people are working with us still collaboratively. So I was just asked the question, when did the building open? Halloween 2022 is the answer, and we're still working. Nick and I work more closely together now than we did on the project because we really believe that this story needs to be told, and it's not so that we can get the kudos of it. It's about passing on the baton to all of you in the room and to others within the industry to make this go further and faster and more importantly have the amplifier effect. So we call Entopia a beacon project for a reason. We want you all to learn from our successes, excuse me. We also want to learn from our mistakes, so we're going to be open about where we succeeded and where we didn't. Just because we're an estates-focused event, here's the movie stages and here's our partners. So the university still has a traditional D&B approach from stage 4 onwards. So the project started, I think, in about 2015, but moved really into construction phases in 2018. And Nick and I were just saying, we had, apart from a swarm of locusts, we had Brexit, we had COVID, we had Ukrainian war, we had all sorts of issues to contend with, and the project came through with us. Also took a pound of flesh from all of us. So what is it? It is a former 1930s BT telephone exchange. It's right in the heart of Cambridge, and it is about just under 3,000 square metres of floor space over 4 floors and a basement. And it is importantly in a conservation area, but it's not a listed building. So we always talk about it having really good bone structure. It had a really good structure. It looks a bit Dickensian in this picture, but it had, some really good constituents to it, but it also had damp, it also had asbestos, like most buildings of this age and stage have, and this is the condition. I think this was after some destructive testing, but this is pretty much the condition we inherited it in. So it looked tired, and what we wanted it to be is a great place where we can have challenging conversations. We can welcome partners from business, government and finance to come to our building, as well as have our people work in a really high quality and a life-enhancing environment, rather than trying to find a polite way to say it. I'll just leave it there. This was not a high-quality environment when we took it on. So what did we do? This is our, and I really realise that this detail is very small for you to see, so we'll just take the principles from it. All of this information is on our website, so please do go and have a look in detail. What we decided is that we should set the ambition very high, and that we should use existing standards as much as possible. So here what you're looking at is the interaction, because in sustainability we all love a Venn diagram, the WELL standard, the BREEAM standard, the Enofit standard, and then some principles around circular economy and biobase. Importantly, we didn't chase credits. That's not what we went in for. We looked for the things that were going to be compatible to our end use and really enhancing to the project in design, in development, and in operation. We think that it's one of the only projects in the UK at the moment that carries all of these accreditations. We are very close to signing off both our BREEAM and WELL. We will be BREEAM Outstanding. We will be WELL Gold, possibly Platinum, and we'll give you some statistics on the Enofit and on the circular economy and biobase in a bit. So it was challenging. And how did we achieve the outcome? Well, not to steal Nick's thunder, but there is no silver bullet here. There is no one technology in Entopia that solves all of our problems, probably unsurprisingly to you all. Neither is there anything that's particularly innovative, although the application of some of the technologies is innovative. What was different, though, is the level of camaraderie, of challenge, of openness, of unity almost from our quite complicated and quite large design team from start to finish. And we did that by setting out our project charter that lived with us from project inception. Before even ISG took on the job, it was actually part of the tender pack. Which set out these things that we believe, as part of our institutional approaches, these are the kind of triggers that we believe are important for the world to adopt. So that real clarity of vision, but also clear alignment to that vision. We accepted that this would be challenging. We accepted that this would need difficult discussions. We accepted that this would need people to stray out of their lane. And we would have to create the circumstances and the conditions for the project team to be able to do that. We had to be really clear on what success metrics looked like and try and monitor those through. And also importantly, we had to target both the behavioural traits that were going to be catalytic to this project and the key individuals who were going to play an important role in this. And we succeeded, but it was challenging, it was difficult, and it was not a traditional build programme or build project. I'm going to hand over to Nick, who's going to run you through the design and the on-site construction. I think it's fair to say that we've got an hour's slides in approximately 15 minutes, so we are going to rattle through them. Both Nick and I will be around afterwards to chat to if you would like.
Hi everyone, I'm Nicola Forrest, Sustainability Manager over at ISG. I'm just going to talk you through the key principles of design, how we approached it, some of the construction issues we had once we got to the site, and then talk you through some of the real circular economy key wins that we had on the project. So the initial strategy for the building, for the Entopia in particular, was to insulate the building from the inside. This was not only for the conservation area, the requirements of the project for the building itself, but out of ease for ourselves. We found a lot of issues on site around thermal bridging and the structure of the building. So once we got to site, we thought it was a brick build all the way through. We started stripping away the walls. Actually, there were loads of thermal bridging issues and issues from where the building had been adapted over time that we hadn't considered. So we found that there were extensions kind of all over the place that had been added throughout, which caused a lot of design issues. Different kinds of wall build-ups were needed. And in particular, the roof where all the initial plant was, the thermal bridging issues there were a real problem. So what we actually did was we removed the plant from the roof, and now that's a really nice roof terrace that CISL regularly hold drinks receptions on. Another major issue with the external envelope was the windows. So originally there was the sash windows that faced out onto Regent Street. These had issues for particularly the lighting of the building. So the building was never meant to be an office. It was really, really dark. Particularly in the ground floor on the basement, there's a brick wall out onto the main road where the buses go past. So we actually went to the planning authority, the planning committee, and proposed clear windows. We kind of went backwards and forwards on this. They said no. We kept pushing from it from a sustainability point of view. Not only was it for lighting, but also for the new windows would be triple glazed for the Entopia standard. Eventually we got it through, and what we did was we actually pushed those windows back. So if you see between the two pictures, the first one they are much more forward in the facade, but on the second one they are stepped back in line with the internal wall, just to get as much light in as possible. And that also again helped with our thermal bridging issues, because we weren't going in and out between windows. It was a straight wall build up on the internals. And then a massive part of this project was the embodied carbon, which was a standard or a design principle set by CISL. Obviously within that, because we retained the existing building, there was massive saving in embodied carbon. The first graphic here shows what the impact would have been if we'd have knocked it down versus new build. The one at the bottom is the saving that we had from keeping the building and keeping a lot of the materials inside it, such as the raised access floor, stairwells, lifts, etc. And just the pink line that comes in is any new materials that were brought to site for the refurbishment. So it just shows the impact really that that's had in terms of embodied carbon for the building. Don't quote me on this, but I think the final embodied carbon figure was 304, something along those lines, which is really impressive for the building. In terms of the internal strategy, we've mentioned the internal wall build-up, triple glazed windows. Task-based lighting is throughout, so I'll talk through the lighting a little bit further on. We managed to do all the lighting almost through circular economy. If not, the ones that were procured new have a take-back scheme end of life. There was no suspended ceilings throughout. It's exposed surfaces, again for an embodied carbon and flexibility point of view. I'm going to talk you through some of these, which is why I'm kind of nipping through it. There's no floor finishes, so it's just exposed raised access flooring, which caused a lot of conversations going backwards and forwards during the design. CSL wondered whether would it work acoustically, would it be noisy, what would the finish look like? But actually, if you're in there, you would never know there wasn't a floor finish. You kind of forget that isn't what the floor should be. And anything that did go in was low impact in terms of VOCs and responsible source in terms of the BREEAM and the WELL requirements. So into construction. So for us, like I said, when we went into the building, we didn't expect it to be an easy build, but there were loads of things that we didn't really foresee that caused us issues on top of the requirements that CISL had given us for the WELL, the BREEAM, the embodied carbon. So when we went to strip out the building, we found this heating trench in the basement that went all the way around the perimeter. Again, massive issues with that for thermal bridging. We had to fill that with a concrete, and concrete's quite carbon intense, so we had to go out to the market and find a really low carbon concrete. And considering this is back in 2020, I think the industry's moved on massively in the last 4 years. That was a real challenge. The second challenge we had, so these columns, we were actually going to leave them exposed. Once we stripped them back, they were just too damaged, they needed to be recovered again. That caused us to procure more materials. There's a lot of VOCs associated with what we'd covered them in. So all these things were just adding up to not necessarily achieving the brief that CISL gave us, but what we had to do is work very, very collaborative with the wider design team, working with the architect, working with BDP, who are the sustainability consultants, to actually understand how all these requirements interact with each other and where potentially things couldn't be met. And it was very much a compromise situation. Like I said before, we weren't chasing credits, it was actually doing what was possible and what was meaningful for CISL. So materials use, just on the back of defining the low carbon concrete to meet the ENOFIT and the bio-based materials requirement that was set for us as a target, was really difficult. There wasn't that many materials out there. So for particularly the ENOFIT, we needed to have insulation with really, really high thermal conductivity, but also bio-based. So we didn't have a lot of options on the market, and there wasn't actually that many suppliers or that many subcontractors that could install them. So our procurement was very, very different to normal. We had to work with supply chains that we're not used to working with. We didn't have any choice of who we were working with, which also adds a level of complexity for the contractor. One of the really great things that came out the back of this was the subcontractors we had on board specifically for diathanite, which is a really, really thin layer, almost sprayed onto the wall before you put the insulation and plasterboard on. Was they spent time with our other dry lining contractor to teach them how to install this diathanite, so that moving forward that they could then tender on projects and work on other ENOFIT projects. And we've since found out that they won projects off the back of that. So even down to our supply chain, there was so much collaboration and willingness to share skills and experience so that we can use this project to move forward as an industry and supply chain. So just on the circular economy principles now, so this is what I work quite heavily on within our ISG, and what I'll say is we didn't go into this project saying we're going to go here and get that light in, we're going to reuse this from that project. We went into this not really knowing what the opportunities were there, because you can't guarantee that materials are going to be available when you need them. But what we did at ISG was we went out to our sustainability team and we basically said, whatever is on projects that are being stripped out in London, or even through other contractors, let's make this a collaborative piece. So every project that we had at ISG, there was almost an action that there had to be a report back to the sustainability team of what was being stripped out before anything could be removed from site. So these lights were installed at St James's Place in central London as part of a Cat A fit out. They'd been in about 3 months and they were being stripped out again. We literally just went to site to do a survey and we saw the opportunity for them to be reused. What we did was we went back to Specialist Lighting Design, who was the designer with the manufacturer, and said, can we reuse these over at CISL? There was a lot of backwards and forwards, and they agreed that they could be reused, and they came to site, batch tested them, took them back to their facility, and they agreed that they would honour their existing warranty on the product, which is a massive thing for Cambridge Estates. They wouldn't have anything on site that didn't have a warranty. Without that, these couldn't have been reused. But that again was just something that never really happened before, and it was a collaborative conversation, and it was just I think the design intent of why we were doing it, and the industry being willing to change the way that they've always worked. What isn't in this slide actually is any lighting that wasn't those strip lights. We've got some Signify, very, very small lighting, sort of kitchen areas, task-based lighting, that was 3D printed. So at end of life, they can go back to Signify, melt it down, and be another light again. So everything there was fully circular. This steel is on the roof of the roof terrace, and This was actually specified to be new steel, and just by chance we made a phone call to Cleveland Steel and just said, do you happen to have roughly this amount of steel? They said, let us find out and we'll come back to you. Again, it was never really the plan, we just picked up the phone and asked the question. They came back and said, we have there or thereabouts, can you send us the drawings and we'll see what we can do. So the structural engineer and Cleveland Steel worked together. They redesigned the canopy slightly to be able to go on the roof with the PV on the top. This steel actually came from Pinewood Studios, and it was the camera tracks from the Eternals movie that they run the cameras down, and it had been delivered about 3 days before we made the phone call. So again, completely by chance, but it's just asking the question. And then this reception desk, again, I went to Netflix in central London, just off of Oxford Street, to do a pre-demolition audit as part of their BREEAM requirement. And this desk was specified to be stripped out and got rid of. We made a quick phone call to the architect on the project and said, what do you think of this? And Cambridge said, yeah, we'll take it. What we had to do here was Benchmark Joinery came to site to remove the desk. They actually, out the back of that, realised that their own joinery isn't demountable and it doesn't come out easily, so they changed the whole way that they install things out the back of this. This went back to Benchmark Joinery. It was modified slightly to fit in the space and to be able to get a wheelchair behind it before it was delivered over to CISL. In the bottom corner here, where this little gold type of Japanese art, where they pour almost like a liquid in it sets, that's where it actually got damaged on the way to CISL. So we said to CISL, we'll get it repaired, we'll get Benchmark Joinery to come and repair it, and CISL said no. Actually, it tells the story of the desk, that it's not new and it's been on a journey to get here. So our architect, Wendy from Archetype, came up, well, she said there's this Japanese style art, we could actually highlight it on the desk. And it's one of the things that everyone kind of looks at and goes to look at after we present at the building about the reception desk. The finishes, so the internal furniture was provided by an organisation called Eve Waldron Design. The real focus here was bio-based reuse and a natural feel. So there was a lot of bamboo throughout, a lot of hemp throughout. All of the furniture came from third-party reuse organisations. A lot of it was reupholstered, repaired, and then brought to site. Some of the tables, which I don't think are on here. The boardroom tables upstairs at CISL are actually made from old army uniform that's been condensed down to create a table, which is really, really interesting to see. I'm going to slip over this, but that's basically what we've just talked about. All the T-points is made from cut-offs of timber, so it doesn't quite match, which we thought, not sure how that's going to look, but actually it looks great. So outcomes. We've got the ENOFIT certification at IHG. We were losing sleep over this, about doing the air testing. We actually passed with only 2 floors finished. So we were really over-designed everything, but it worked. We've got the certificate for that. In terms of ENOFIT, it's the largest, well, one of the largest commercial buildings to be certified. Most of these buildings on the graph here are residential. So it just shows it's possible even at that size. Bio-based materials, I think we were set a target of 70% bio-based. We actually got 34.8% because it was so hard to find bio-based materials on the market that also had the BREEAM and the WELL certifications. We talk about this a lot, about if we did it now, actually I think it could be even better. I think there's a lot more bio-based materials on the market. I'd be really interested to work on a project now where I think that could be pushed into the 50s or the 60s, just how far things have come in the last few years. Metered energy use, I'm cautious I'm running out of time here, just to show how much energy has actually been saved from the ENOFIT. So after refurbishment is on the far right hand side, so you can see the dramatic energy reduction out the back of the ENOFIT. Commercials, I did get asked this question just before you guys all came in from somebody in the room. So on the green bar chart, the green chart is the cost of CISL. So that just shows that it can be built and done on average with other commercial fit outs. I will say here that this was a benchmark kind of guesstimate quote because we had to remove unforeseens for Brexit, for COVID, for the Ukrainian war. But what we've done there is try to demonstrate that it doesn't cost loads more to do this compared to other projects. And in terms of legacy, obviously, you guys are all here today because you're interested in it. We've had a lot of interest really across the industry from it. It's become an absolute case study and a project that's inspired lots of other ones in the industry, and it's won lots of awards, which has been great for the awards ceremonies that we've got to go to. And just really key lessons learned is the client buy-in and the client engagement. Having a client that did put it at the top of the agenda completely led the way, and it actually made some of the decisions and the trade-offs we had a lot easier because there was always somebody available and someone willing to say yes or no to this, particularly around the circular economy. There were quick decisions, quick wins, and it kept it at the top of the agenda. Yeah, I'm not going to whiz through all these, but I'll give some key highlights. Use innovative materials. I think we spoke to lots of suppliers that we wouldn't usually speak to, and they worked. And yeah, there was no single framework really, and it was trying to understand how we could achieve everything, or where the best compromises were to be. There's just some of the awards, and yeah, there's loads of stuff out there if you want to read more. Or me and Anna will be around at the end if you've got any questions.
Brilliant.
Oh, and this just really quickly was the hoarding that was around the building throughout the build, and it was a tagline that one of our marketing team came up with, which I thought was really, really powerful. Thank you.
An outstanding project, and I think it's really important to see there that in many cases it's the value engineering that removes the sustainability or the budget demands, but the client here has been very strong with a great vision, and it just shows you when you put your mind to it, when you get the right people, it can be delivered. So well done, team. Any questions? Must have been a really good presentation. Right.
I was wondering if you didn't have that vision really clear, aspiration from the clients, what would you have done off your own back? I mean, what elements would you have kept that weren't necessarily?
I think we always, particularly when you have sustainability clients, we always have that. We always have a vision of where things want to go. But as it was mentioned, a lot of sustainability is usually the first to come out when things get VE'd or there's program pressures. This just meant that there was none of that almost escape route for sustainability. We put that charter even through our supply chain, and then it went through their suppliers. So even at every meeting, it was more about the sustainability requirements, where that isn't usually the case on a project. It was up there, probably more than cost for us to safeguard those requirements. But on other projects, while we do have that, it's not anywhere near at the same level, which is how it should be, or where I'd like it to be at least.
Go ahead.
Hi, Neil Stanley from McAvoy. Just out of interest, because you said in terms of per square foot, the cost of the fit out was sort of roughly in the middle. In terms of programme, where did it sit?
Programme was completely all over the place, if I'm honest. But that again is because we had COVID, we had a lot of unforeseens. I think you're going to get the asbestos, the unknown construction problems on any retrofit, because once you start stripping things back, you don't really know what you're working with. But this programme was quite horrible. But we hope we don't have COVID. We hope we don't have another Brexit. But we haven't really been able to benchmark what the impact of that. I think we were about 6 to 8 months behind.
Yes,
behind PCing.
We were, but I think there were certain elements that are very clearly linked to the sustainability. So the battle with the windows with the council was a prolongation, which we actually just took on the chin and said this is really important. We're not going to meet the criteria that we think are really essential for this build unless we win on the windows. So there were certain things where we implicitly took it on the chin that the programme might be impacted, and a lot of the other stuff was almost a just-in-time transaction around supply and demand for the marketplace, which our programme tolerated, but luck played into it, got to be honest, and some of those we had to then take additional steps. So the furniture reuse, because we had some delays at fit out because of the Ukrainian war, we had to pay for holding, storage holding, because the supply of second-hand furniture is on a it's here, it goes basis. They're not in the storage, so we had to take some additional costs at fit out that wouldn't have been ordinarily in a budget, but we took that view that it was important to support the circular economy principles.
And yeah, and the bio-based stuff, you know, some of the insulation that we were putting in wasn't off, you know, we couldn't go and just buy it off the shelf. There were a lot of lead-in times for ordering the bio-based from small manufacturers in the quantity that we needed it to. So it's really hard, it's hard in terms of programme to compare it. I think with retrofit, it's always going to be a longer programme.
Thank you.
Another question here.
Yeah, Simon Cash from Artalia Projects. A project like this, which is very unique, must have been contractually very challenging as well. How did you deal with the issues in what form of contract and still stay friends?
It was NEC 4, I think, I mean, as a client, I was lucky enough because as part of the university we have an estates division who are actually the client, the main party. So I was there as a departmental representative, which actually kept me in an empowered position to say that can be dealt with by our estates team, the finance teams, and separate. I think we had to really fight to keep the relationship good at times, let's be honest. You know, when you're dealing with supply issues, you're dealing with Brexit, you're dealing with things that are going to cause prolongation. But we had to work to know that actually we would all come through this and that there was a bigger goal at the end, and that fundamentally if we couldn't stay friends, we wouldn't be able to talk about this. Probably we wouldn't be able to be in the same room. And so some of that is we just had to shake hands. But also that separation of duties. The project team had a focus on programme and on delivery, and some of the other functions within the university were able to deal with early warnings and all the kind of, you know, the difficult decisions. So I was lucky. I've been on the other side of the table, but I was lucky in that circumstance.
And you might know slightly more about this than me. There was a joint risk element on the contract,
yes,
as well, which helped things, which kept things from necessarily disputes happening. But from an ISG point of view, we did have a lot of dealing with contracts with suppliers that we've never worked with before, which caused us a lot of headaches, or actually meant that we had to be more cautious because we weren't working with our approved tier 1 contractors that we usually do, or we had to go through lots of pre-qualification questionnaires with some of these supply chains to get the funds supply chain whilst against programme. It was just there was layers of commercial complexity to us, but it was made easier by the fact that sustainability was at the top of the agenda, because it would have been so easy to go, we'll just procure that from somebody else. But commercially it was quite difficult. It was difficult to manage.
And I think there was just a level of integrity and honesty on both parts. I used to get a call just to say, I'm not going to lie to you. This is going slow, or it's difficult. And as a client, that puts you in an empowered position where you can say, right, I can start to look at things, I can start to practically deal with things, as opposed to the silence or the sort of, no, it'll be fine. You know when you know. So I think that honesty and that level of relationship, which I think came through the project charter in the first instance, but kind of radiated out into other places after that.
Great. I think we'll just wrap up there. Thank you very much for a very good presentation. Let's move on to the next presentation, Net Zero Pathway. This is about the heat network at Leeds University. We've got with us Anne Allen, Director of Campus Innovation from the client side. We've got Nick Boyd, who's a Director at Borough Happold, who led the team. He's a Director on the energy consulting side. And his colleague, Lara Balash, who is an associate on the energy consulting team. So, guys, take the floor and take us through this journey. Thank you.
Oh, sorry, I do.
Or
I think you want to say the please do it.
Well, I'll just talk anyway. I do love collaboration. Isn't it lovely when people jump up and help you and you look useless? Thank you.
Never happens normally.
I was responsible for doing that.
I just thought I did a really good helpless, I don't know what the heck's happening here moment. So I'm Anne Allen, I am Director of Campus Innovation and Development. What that title means is I head up the Facilities Directorate. We are responsible for the net zero element of the university's climate programme. The programme is a comprehensive programme covering everything from governance through to curriculum, through to research, through to our investment strategies, a whole range of things. But net zero sits with myself. And in that respect, it is probably one of the most challenging things we're dealing with at the moment. And a real contrast in many ways to what you've just heard, but there is some key similarities with it. First of all, we have made a commitment to be net zero by 2030, and that's what we'll do. We're not going to compromise with that. So in the same way as in Entopia, there wasn't a compromise around some of those things you wanted to achieve, that's where we are. The second thing is leadership. So up until 6 months ago, our Deputy Vice-Chancellor was the senior leader and senior accountable officer for our climate programme. He's actually stepped away because he's currently in an interim role as Vice-Chancellor. He's currently interim Vice-Chancellor, so we now have the University Secretary who is stepping into that role. But that means we have senior leadership for everything that we're doing around this. Thirdly, there's money committed. So the university have committed 174 million towards the climate programme, of which 150 odd million is for net zero. That means that just shy of 50% of the capital plan is committed to net zero. We're not doing big builds, we're not doing major refurbishments, because the view is, let's get our energy sources sorted out first. Let's get to a point of net zero, then we invest in our buildings. And I think that was quite a brave commitment and a brave approach. The approach has changed as we've investigated. So again, we've had to be flexible. You start thinking this is going to be about building retrofit, but actually, if you want to make a difference at a pace, it is about energy sources. It is about what we can get out of the ground in terms of thermal energy. It's about how we buy our energy, and it's about working in collaboration with our researchers. Actually, in our case, with our hospital trust, which are just across the road, and we have a shared facility with, and with the city. So it's something that we can't do on our own. That's all I'm going to say, because there are people who can talk to you about the technical side, which I definitely am not going to do. But whilst a very different project, I think there's real similarities, and I think that's what we all have to take away if we're going to deliver on these objectives. You can.
So Eurohospitals came into this project at maybe back end of 2019. So at that point, the university had set its commitment to net zero carbon by 2030. And what we were tasked with was looking at developing pathways to get to that target around the existing energy systems on the estate. One of the big headaches at the University of Leeds is their existing steam network. So they have a big energy centre with a load of big gas steam boilers that's generated centrally and then distributed across the campus. So there's issues with that in terms of not just the fossil fuel generating plant at the energy centre, but also a lot of the systems in the buildings, buildings that needed steam for process uses, but also heating that was run off steam systems as well. So what we were looking at as part of the net zero pathways study, this was leading up to the university publishing its climate plan and committing the £150 million to decarbonisation activities. We were looking at what pathways they might take and what options there were. So looking at the balance between retrofit of buildings and transition to new technologies and renewable energy. So the way that we approached this was through a series of different models. Anne's mentioned about the need for a flexible approach, which you'll see as we go through the slides. That was something that we really took to heart in the whole way that we approached this. So there was a series of tools here that we developed to enable not just us to analyse the estate and analyse the energy demands across the different buildings that we were looking at, but also to be able to push that into other climate-related activities that were going on in the university. So being able to layer on top not just estates and energy activities, but being able to layer on top EV charging and Scope 3 emissions activities. So what we started with was a demand model where we were baselining out what the demand at the estate was. So using a mixture of existing meter data and other bits of information from across the estate to build a kind of virtual picture of what the energy demand looks like now and that would be forecast into the future. We also had a retrofit model, so a model in which we could push and pull different types of interventions. So that includes fabric interventions and also systems interventions to look at the impact of different retrofits in terms of both cost and energy demand. There's also an energy model that goes alongside that looks at the district heating scheme, and then a techno-economic model to provide that kind of look at the paybacks of the different interventions and what that might look like over a kind of 40-year period. So as a kind of quick overview of this slide being how we looked at balancing the cost impact. So the chart on the right-hand side shows a few of the different interventions that we were looking at. So the pink points being a few different retrofit interventions. So along the y-axis, you've got the heating demand saving, and along the x-axis, you've got the cost of intervention. So your top left corner is your interventions with good savings and low cost, and then your bottom right would be poor savings and high cost. So we're wanting to get to interventions that are above those payback lines of which different technologies you might go for. So what we found through that analysis was that your fabric insulation and double glazing are really great for having really high savings potential, but the cost is really high. With a commitment like net zero carbon by 2030, we were wanting to prioritise interventions with best kind of cost benefit at this point, and then move on to more extensive retrofit at a later date. So what happened then is that you've got the kind of traditional approach to sustainable buildings design on the left-hand side there, where you're talking about the form and the fabric, and kind of then building up there to renewables. What we found through going through that process and starting to cost up interventions at a really early stage in setting the pathway is that we were moving more towards a renewables first type hierarchy, where you enable your heat pumps and your electrified heating systems to happen first, and then move on to services interventions and then fabric interventions. So the University of Leeds Climate Plan then details a few different scenarios that the university looked at. So I mentioned how we had a series of tools that we were able to hand over to the university to push and pull different levers in that modelling to work out their own kind of bespoke pathway after we had already developed a kind of pathway to net zero carbon. So this first scenario here is looking at a lighter retrofit to the buildings and moving to a waste to energy system for heating. Scenario B is looking at a light retrofit of the buildings with full electrification of heat, so relying on on-campus electrification of heat through things like heat pumps and electric boilers on site. And then scenario C was looking at a deeper retrofit with the heat pumps and electric boilers. At the end of the kind of the climate plan, it concluded this light retrofit with full electrification of heat would be the preferred option. And you can see here that we're kind of, the university has been layering on top of that, not just the impacts that we worked out from modelling of the energy demands on the campus, but also
also loading in their kind of scope 3 emissions there and commuting and business travel and behaviour change. So as part of the net zero pathway for the energy systems, we were developing an implementation programme here. So this just details out how we were starting to plan work to 2030 to make sure that you were doing all of the retrofits that were possible and were needed to install electrified heating systems. But I think one thing to highlight here that's applicable across the board really is that the first action is to update the standards and guidance around refurbishment and O&M, making sure that all of your standards are set up so that even in maintenance and routine work where you're going into, where you might be replacing like for like, you know, valve for valve, that you're actually starting to plan it in a way that any replacements and maintenance are done in a way that is flexible to future decarbonisation. Making sure that that happens at the beginning is really important. So again, moving from that pathway into what the university itself has developed is a timeline to net zero that incorporates the energy-related activities along with all of the different streams of work around decarbonisation that the university is committed to. So our engagement then, so that comes to the end of our engagement to develop the pathways to net zero and the climate plan that really set out the university's direction of travel, and that was the first place where you saw this commitment to £150 million of investment in decarbonisation. And Nick's now going to talk you through our ongoing engagement with the university as they're moving into implementation of these projects. Yeah.
Get it right, Leslie, for a start. Yeah, hi everyone. So yeah, as Laura said there, the sort of the scene was set. The funding was there. So there's now a case of actually what are we going to do next? And we've put this slide up here just to show you that really focusing on a handful of really key elements and focusing on them and really committing to them yields the best outcome. So we're really focused on going from numerically here, the building retrofit studies as a starting point. So a number of buildings were selected and targeted across the campus. And, the university campus is a really huge campus as well, so it's very important to be targeted. An electrical infrastructure study was also undertaken, because if you take anything away from this talk, and we've got it right at the end, is electrification of heat at this scale is a huge undertaking from an electrical infrastructure point of view. So if you're going to start anywhere, focus on the electrical infrastructure and speak to the local DNOs and the utility companies. A really exciting part for the university is the ground energy element to the university. So right now, again, the university is putting their money where their mouth is. So there's a really extensive drilling and testing program happening at the university at the moment. Multiple closed loop and open loop boreholes and water wells are being constructed, yielding really good positive results. And just wanted to mention on this particular point is, again, the buy-in from the university. The academic side of the university have got hugely involved in the ground energy investigations, so it's actually becoming part of the teaching curriculum. They're putting a load of monitoring points all through the ground system, so they're getting a huge amount of data for the curriculum and the academic buy-in as well, which is fantastic. Really key part of the transition away from the high temperature steam network that Lara popped up before is that we're disconnecting buildings from the steam network and going to individual more clusters with decentralized energy centers, so linked to the ground energy systems. So, moving away from very inefficient high temperature fossil fuel heating systems to very low carbon ground energy electrification of heat systems, connecting maybe sort of 4 or 5 buildings per cluster rather than a huge system. We've mentioned the existing steam heat network as well, which is called the GSC, so that's the number 5 there. That we can't just instantly turn off from the steam network, because it's a huge network. So targeting some clusters to disconnect is part of that journey that Lara had up. But the other part of it is to remove the gas-fired plant from the large energy centre and replace that with electrode boilers. So we're still delivering steam to parts of it, but it's steam created from electrification of heat rather than gas. So that was a big part of it as well. And then the final element was, going back to the electrical infrastructure again, is not just thinking about 2030, but this is a longer term vision, is what does that electrical infrastructure look like across the campus by 2050? And yeah, that yielded some very interesting results, and the impacts can be extremely large. With, I think we needed 36 MVA of new capacity, new substations for the campus. That gives you a feeling for the scale. So you can imagine the conversations with Northern Power Grid in this text there. So just picking up on those points. It was removal of a number of the building clusters from the steam network, electrifying steam production for main buildings, and reducing the energy consumption across selected buildings. So there, like I said, focus on 2 or 3 really key elements. So just focusing a little bit more on those individual elements, actually removing buildings from the steam network. 21 buildings were selected, and like we mentioned, we talked about trying to get demand reduction built in, but not the only focus of everything. So we really focused on that. How are we doing for time?
Got 5 minutes.
Oh, okay, good. Electrification of steam production, as I mentioned, the electrical load increase was ginormous. So that's, I'll mention it 4 or 5 times. It really is the absolute key thing to take away from this. And then building studies, as I mentioned, multiple buildings were focused on. The buildings that were on the sort of the outline of the campus, so ones that we couldn't quite reach, associated with the heat network or the cluster approach for the new heat network, they were focused on in a much more refined way. And then the final part, which is still in development, is thinking about smart energy strategy. So looking at controls, looking at how we integrate digital twin technology into the whole project. And that's digital twin, not just from, so people understand digital twin in a slightly different way. On one hand, it can be literally a digital record of everything from an operation and maintenance perspective, which again is a huge undertaking, but also from a dynamic point of view, so actually monitoring energy usage and monitoring and being clever about how you manage around that. Okay, so just to try to wrap all of that up into absolute key takeaways for you. Lara's mentioned about the approach, and the demand model right at the beginning is the absolute critical place to start, really. So you have to try to get an understanding and also a visualization, which is key for the client in the first stage, of your existing energy demands across the site. Now that, on a site as large as the university, can be extremely challenging because that data, in a perfect world, that's held in a lovely single repository, but in reality it's not the case. So you're trying to build that whole picture up, so that's super important. We've mentioned a few times about the stakeholder buy-in. Anna's mentioned this commitment. It's impossible to do it without that commitment from the client side. And I mentioned the academic side of life as well. We're here at a university estates event, and I think more could be done around the link up between these projects and the academic side of life, because it's easy learning, it's immediate learning. So I think that's a really strong thing to take away. Identifying low-grade heat opportunities as well. We've talked a lot about ground energy. We're quite lucky in a way that at the university, the geology and the hydrogeology is quite suitable for ground energy, and also because it's a huge campus, you actually have space to implement borehole systems and water well systems. But we did look at other opportunities as well, including surface water, wastewater, so from sewage, for example, and also industrial waste heat recovery as well. So, at very, very early stage, look out for those. We've talked about, is fabric first right? And again, this is looking at a whole estate point of view rather than just like an individual building. Electrification, again, it's so important. Not only just with the electrification of heat, but electric vehicle use as well, and early engagement with your DNO is. I think I've said it in 1 minute. When we're talking about low carbon heating systems, optimization is really, really important. When we've been looking at the decentralized energy centers, we're really maxing out on thermal storage where possible. So we're trying to absolutely minimize the actual heat generation plant as much as possible, which has the knock-on effect of minimizing the ground energy that you need to go to that plant. So, real pressure on that is really important. Easy wins are, on-site renewables, especially when you have a large estate. Things like car park PV canopies are really easy and are a nice easy win. And then the last two around programme and cost. We've seen that the university really took it seriously with the programme. It was a really genuine attempt at a costed programme that is being followed as well as a commitment to following that costed programme. I think that is about it.
Excellent.
Thank you. Just in time.
Thank you. Round of applause, I think. I think for me, it's really, really great to hear someone saying we are not going to waver from net zero 2030, because that's one thing that I've seen across all industries that is just a number. And when I hear a client say we are not going to waver from 2030, that's really important. But clearly, you've got a very competent team supporting you as well. So excellent project. Any questions from the audience? We don't have much time. Go ahead.
It's actually that last point in terms of the operational cost. With the huge, you've emphasised it many times, the huge emphasis on all electric and the sort of not going fabric first for understandable timing programme reasons. Have you modelled the operational costs so that you're comfortable with where that might go? Because it strikes me that could be quite an expensive operational strategy.
Yeah, absolutely. And then with all large-scale university campus projects, you can't hide away from the increased operational cost of going to electrification of heat. If you, saying about the optimization, if you really, really try to work hard on what you're doing with the low-grade heat sources, your coefficients of performance on heat pump systems, the differential in electricity price to gas price, you can start to level that out. You're absolutely right to raise it. It's an operational cost. Challenge.
Client view. It's a huge challenge, but it's going to be my lever for reducing the size of our campus, because we will not be able to afford. So if really the whole emphasis of this is to reduce and use things more efficiently, actually by going this way, knowing that it's horrendous for our budgets doing this, that gives me another two. Please don't share that with them.
It's a very good point, and it's the way a lot of the public sectors do. We just have to downsize and better use our facilities. Any other questions?
So doing the fabric last and electrifying all of the systems first, does that mean that in the end you're going to end up with an oversized plant that is running inefficiently when you do get to do the fabric retrofits?
Really good question. Yeah, really good question. So the answer to that is that you mentioned it just at the beginning, it's about the timing of things. So really focusing on the quick wins. What can we do now within our
I
current
get that we're up against
infrastructure
it.
budget? Yeah, so it is quite program driven, but the system changes that we're doing now are only for a percentage of the buildings. So as we're focusing on the building demand reduction in the outlying buildings specifically,
So
they will have their own.
anything with an independent system, you are doing the fabric interventions to have that long-term impact.
Yes, yeah, that's right. Yeah, so we're focusing on the immediate dealing with the buildings as they are now, and decarbonising the heat specifically, and then the other buildings where we're focusing on, which are often the outlier buildings from the current main steam network, focusing on demand reduction in those buildings, and then the systems will be sized appropriately to demand reduction.
Right. So you're on the outline buildings, you're doing the double glazing and the.
That hasn't quite been decided yet, so that process is.
So we don't know yet.
Yeah.
Right.
The problem with anything like this is currently you're looking at this in isolation. You're assuming that we're not looking at other things on our campus.
No.
So, you know,
I'm
so
just thinking.
no, yeah, but what this runs by the side of is the fact that we are remaster planning our campus. So we know that a number of our buildings will change.
Mm-hmm.
So again, by doing it in this route, it gives me more flexibility in terms of which buildings and how we use them. And we may end up using some of these that we're doing at the early stages far more intensively. It gives me that opportunity. So it's sort of looking at it quite strategically, as well as operationally, as well as having a very hard target to hit.
So you're saying that
those together.
by
And it'll be
increasing
iterative.
the usage intensity, you're going to increase the cooling demand, and therefore you will have that higher capacity because you're looking.
So we can start to look at that, and it'll be iterative, and there will be, I can almost guarantee now that by 2030, some of what we do now, I'll think, I really wish we hadn't have done that. I wish we made a different decision. But that's called the built environment, isn't it? Because, you know, we build and we spend on it long term, but we'll have greater knowledge.
And then you can play it back to us again. And then
Last question. I think if you need to speak to any of the speakers that you're going to be around, right? I think we have got a question. Did you?
I mean, I was just interested, is this a strategy that's come down very specific to your site, or do you think this is something that could be transferable to most of the... and is this something I was just wondering, because it was a steam local, a sort of centralised steam system, that's improved this strategy or made it ideal for your, or is it something that could be transferred across the board to all universities?
We've worked on other university projects where they've also had existing older steam high temperature networks, so obviously it's an applicable methodology for those projects. But even where they haven't got that existing system, a lot of the principles here ring true. Again, my favourite word, the electrical infrastructure. Yeah, that is an absolute constant across all university campuses. We're working on a project with Durham University at the moment, and it's the same conversations keep coming up. You know, if you want to try to do something in the reasonably short term, you know, a good one is to just review what your available headroom is, for example, in your electrical infrastructure, and see what heat you could decarbonise within that bit, because that's what you can do. You could get on and do that tomorrow, for example. Whereas the longer term, you know, looking on 2030, 2050, strategic effect on electrical infrastructure, that's a slightly harder problem to solve, but you can act quickly with what you have.
I mean, I suppose also at scale, like universities, but only you look at sort of schools that go for strategy of getting heat source heat pumps, and then find that they can't afford the equipment.
Yeah.
So I mean, I suppose it's a sort of question of whether it works at your scale, but doesn't work at a smaller stage.
Yeah, I think University of Leeds is a reasonably unique example because it is very large. It's a very, very large campus, and the demands are huge. So you can make quite extreme impacts in the short term. But I do still think there are some of those key elements of the methodology can stand across. Yeah, whether it's a smaller school campus or a commercial campus. Or
a quick one.
Yeah, it's quite hopefully quite quick. So, Alan, you mentioned collaboration with the NHS trusts, and you didn't go on to explain that at all. And also, there's a heat network in Leeds already. So, was there a reason why you are putting those things together with your campus?
So the reason why we are looking at the trust is because we jointly run the GSC. Right. So that big generating station, we jointly run it. So we collaborate anyway with them. But we're also looking at them in terms of things like the electricity demand. They have one of the models in the future being developed. It's really important that we work closely to understand what that means for the demand. So when we put our request into Northern Power, which we're just about to do, so that we can get electricity in 2028, we've worked really closely with hospitals to make sure that they don't come along next year and go, we'll have a bit more, please. The other thing we have got running is a just transition programme, so that we are not impacting on our immediate communities, some of which are, we have some areas of deprivation around the campus. So actually it's really important that we don't basically take all the electricity away from future opportunities. We work very closely with the city, we work very closely in terms of everything that we're doing around this. But because we've got this existing network and because we have this 2030 commitment, this way we can manage it ourselves, control it and ensure that we deliver to it. And I don't actually think we're missing opportunities because of the scale and size of what we are.
Just quickly to answer so there's the Leeds pipes system, which is in Leeds, which is mainly delivered from a large energy from plant in the outskirts of Leeds. So that was modelled in one of the early scenarios, but for different reasons, from carbon factor to also Leeds wanting control of their own destiny on the site, led to that particular option of extending the network up to the campus being discounted at that time.
Great. I think round of applause for our present presenters.